So we did up till the reaction of oxides with water. We had to start the reaction of chlorides with water, and this was known as hydrolysis. And I think I did briefly cover this in the past paper class, but I'm going to do this anyways again. So now the reaction of chlorides with water is that if you have NaCl, NaCl, remember, only dissolves, nothing happens, only dissolves. MgCl2, on the other hand, for MgCl2, remember this. I mean, I need to make some corrections to these notes. Sometimes this is, I mean, this equation is fine that I've written over here. Uh, but MgCl2 mostly dissolves as well. So if somebody is going to ask you about MgCl2 equation, then you have to write it's going to be MgCl2 solid plus you put it in water, that's aqueous, and it's going to ionize and dissociate into Mg2 plus and 2Cl minus 1 aqueous ions. So this is what's happening to MgCl2. The hydrolysis part is very slight. So there is very slight hydrolysis. I'm going to describe hydrolysis in a short while. When it comes to AlCl3, then the hydrolysis is very strong. You have very strong hydrolysis. It reacts with water and ends up forming a white precipitate. I mean, this is a white precipitate. And whenever HCl is formed, remember this, that white misty fumes of HCl are going to be seen. They're going to be seen. So there's going to be strong hydrolysis. So the question is, what's happening? And I had described to you that when you have ions in solution, the correct equation for AlCl3, I mean this one, the new marking scheme actually doesn't use this equation. The new marking scheme, what it uses is this equation that it AlCl3, when you dissolve it in water, it first mixes with water and ionizes, ends up forming Al3 plus aqueous plus 3Cl minus 1 aqueous ions. And then what happens is that the aluminum ions, they attract water from all sides. These are known as complex ions, which you're going to study in detail in your A levels. So these are your complex ions. So aluminum ions are going to get surrounded by on all sides by water molecules, because water molecules are polar, and the aluminum ions are going to attract water molecules, and these water molecules have this oxygen, which is partial negative, and it has lone pairs. All the water molecules are going to stick to this aluminum ion. And the H is partial positive. So the H is partial positive, and the H, on the other hand, is going to get repelled. What eventually happens is that the water ionizes. The H is getting repelled by the aluminium, and the negative part is getting attracted by aluminium. And that is what forces the water to ionize into H plus 1 and OH minus 1 ions. And eventually, what happens is, just one second, eventually, what happens is that the water molecule ionizes, and this Al3 plus aqueous, which is Al surrounded by six water molecules, that's a complex ion. It starts to ionize and it starts to produce Aluminium hydroxide. That's the solid that's getting formed, and the H plus one they start to dissociate. So this is the equation for aluminum chloride hydrolysis that's usually written in the marking scheme now, which I don't get because you haven't studied complex science. It's going to come in A levels, but they're using this equation now. Previously, the old equation was that you got aluminum hydroxide and HCl. You're getting HCl over here as well. It's H plus one and Cl is getting produced, and they're going to combine to form HCl. But they want a more detailed reaction now, and that's the detailed version of the reaction that you have to give in your exams. Okay, so why does aluminum ions hydrolyze water? Because aluminum has a very strong partial positive charge, not a strong partial positive charge, but a very strong 3 plus charge, and which ionizes the water molecule. Na plus one could not do that. Na plus one, if there was Na plus one over here, then Na has a very weak plus one charge, and it's not going to repel the H plus one that strongly that the water breaks or ionizes. So this doesn't really happen in Na plus one. It happens to an extent in Mg2 plus, but only very slightly. But in aluminium 3 plus, this thing happens a lot, which is why you get aluminum hydroxide, a solid white precipitate of aluminum hydroxide, and HCl gas is produced as well. And a strongly acidic solution is produced because a lot of the HCl is going to get dissolved in water as well. Okay, is this part clear, Bhaskar? Mohammed, Ethan, is this
Yes, sir.
Abba, is this clear?
Yeah.
Asha, so and then the hydrolysis continues. SiCl4, this further hydrolysis, uh, PCl3, PCl5, they mix in water and they form acidic solutions as well. And the same thing happens. Uh, and remember, I mean, these minor points should also be that you have rapid reactions and misty fumes of HCl are released. The next part is the acidic and basic nature of oxides and hydroxides. Uh, Metal oxides are basic, so sodium oxide, magnesium oxide, or hydroxide, they all react with acids. Uh, Aluminum oxide is amphoteric, which means that it could react with both HCl and with NaOH at the same time. And SiO2 is very weakly acidic. Remember, SiO2 sand was used in the blast furnace for the extraction of iron, in which you added calcium oxide as a base uh, to get rid of SiO2 in the form of slag. But that required a very high temperature in the blast furnace. So SiO2 is very weakly acidic and it forms silicates. And these ones, phosphorus oxides, sulfur oxides, these are acidic. And also remember what type of salt is going to be produced, because if it's P4O6, we've already discussed that P4O6 reacts with water to form H3PO3, and P4O10 reacts with water to form H3PO4. So remember what acid is going to be formed when you have to write an equation with P4O6 or P4O10. What you should think of is that you should think of P4O10 as H3PO4, as if you're reacting or making an equation with H3PO4, and then you can figure out the salt. Similarly, if you're reacting a base with SO3, think of SO3 as H2SO4. Then it would be much easier to figure out what the salt is. It's going to be sodium sulfate, and a water molecule is going to be produced. Um, so think of these oxides, these acidic oxides, as acids. And the last part is the ionic and the atomic radiuses or radii. Why does the atomic radii decrease across the period? Because they have the same shells. So you have the same number of shells, but the protons keep on increasing. And since the protons are increasing, the shells are strongly attracted to the nucleus, which is why the size of the atom gradually decreases. Positive ions are obviously cations are smaller in size. Why? Because they lose their outer shell. Negative ions are bigger in size because they gain electrons, and there's a lot of electron-electron repulsion because of the extra electrons, which is why they're bigger in size. Then dimerization of AlCl3. Hopefully, you know this. That what happens in dimerization, that aluminum has one outer shell that's incomplete. Like its outer shell is incomplete even after bonding because aluminum has 13 electrons. 13 electrons meaning that its outer shell has 3 electrons. It's 3s1, 3px1, 3py1, and the 3pz is 0. So when it bonds with other atoms, it forms 3 normal bonds. And even after forming 3 normal bonds, one of the orbital is completely empty, and that other orbital is used. It attracts lone pairs from other atoms. So, for example, Cl has lone pairs, lots of lone pairs. So, a fourth bond could be formed, a dative bond could be formed, and this is your dative coordinate bond. So, that's going to be formed with the Cl of the neighboring AlCl3, and a dimer would be formed. And then you have to remember the flame colors. Na is bright yellow, Mg is white, bright white. Aluminium is also bright white, and silicon, on the other hand, has a slow reaction. Phosphorus has a yellow flame, and white cloud of P4O10. So you have to remember this. Uh, Sulfur has a blue flame. So remember all of this. So this is period three. Now we're going to do some past perfect questions related to period three. And let me just open. Now, the thing with inorganic chemistry, most of the questions are just about memorization. It's you don't have to really think a lot. So if you have memorized these 3-4 pages very well, you should be able to do the question straight away. So let me just find. So let's do this one. Okay, I've already sent this paper one worksheet. Just 1 second. Let me. So let's start with period three. Now, the question is which oxide, when mixed with water, will produce a solution with the lowest pH? Okay, the first one. The lowest pH. Starting with, so which oxide was acidic? Just go back, have a look. Which one was the most acidic oxide? It was, you had these, it was either phosphorus oxides or sulfur oxides. These were very acidic. So it's going to be phosphorus oxide. That's the one that's going to be acidic. SiO2, remember, would not mix with water. It required high temperature or concentrated NaOH. This is sand. I mean, sand, although it is acidic, but it's weakly acidic. So that wasn't going to react with water. Carbon dioxide, sodium oxide is not acidic at all. It's a basic compound. Metal oxides are basic. The thing with carbon dioxide is very slightly soluble. And any carbon containing acid is not really a strong acid in the first place. Like if it's going to mix with water to form carbonic acid. But remember, all carbon containing acids are weak acids. So it's going to be phosphorus. This one will produce H3PO4. Now next one, when added to water, which oxides will not cause a change in pH? Now the first one is true, it's correct. Why? Because it's not soluble. It's not going to mix with water in the first place, so it's not going to affect water. And the second one is also true, not soluble. Somebody's mic is on. Acha, and the third one is true because it's going to mix in water and it would form H3PO4. So since the question was not, the first two are the ones that are the correct answer. Acha, the next one, which of these substances have a giant structure? Remember, uh, clay and SiO2 are basically the same thing. So that is a giant structure. SiO2, we even drew the structure somewhere over here. Okay, on this side. I mean, this was what silicon. We drew the structure of silicon, not silica. But you know what the structure of silica is. So that is a giant structure, SiO2. And clay is the same thing. Phosphorus oxide, remember, is not a giant structure. This is simply P4O10. It's a simple molecule. So it's simple molecular. Now next one. Elements X and Y are both in pH 3. When the chloride of X is added to water, it reacts and a solution of pH 2 is produced. So the chloride is acidic. Whose chloride was acidic? It's either going to be phosphorus. So it's going to be phosphorus chloride, or I mean, which chlorides were acidic? Let's have a look. Silicon chloride was acidic as well. Aluminum chloride was also strongly acidic. So all of them, starting from magnesium chloride, that had a weak hydrolysis. Aluminum chloride had a very strong hydrolysis and would produce a lot of HCl. Silicon chloride also did that, and phosphorus chlorides, they were also obviously acidic. They would form acids. So it's either phosphorus, aluminum, but it's strongly acidic. So I'm going to remove magnesium from it. So it's either going to be phosphorus, aluminum, silicon. These three. And then there's the other one. The chloride of Y is added to water, it dissolves in a solution of pH is produced. The only chloride that only dissolves is Na. So which statement explains this observation? The observation is both chlorides hydrolyze in water. They don't. NaCl does not hydrolyze in water. It only dissolves. So the first statement is incorrect. The second one is, okay, X is phosphorus and Y is aluminium. That's also wrong. I mean, Y is definitely sodium. So X is silicon. C is going to be correct. Okay, is this clear? Ethan, Mohammed, is this clear? Bazga, Ibrar, Rida, is this clear?
Yes, sir.
Yes, sir.
Achha, so next one. Element X and Y are both. I mean, this is the same question actually. This one. He's talking about SiO2, the structure of SiO2. So, what happens in SiO2? You have Si bonded to four oxygen atoms, and then those oxygen atoms are further bonded to silicon atoms. Okay, so what happens is, what is X? Each silicon atom is bonded to two oxygen atoms, and each silicon atom is bonded to four oxygen atoms, and each oxygen atom is bonded to two silicon atoms. So it's going to be 4 2, and all of them are covalent compounds. So it's going to be C. Next one is, which element has the greatest tendency to form some covalent compounds? Neon is totally out of the question. It's a noble gas. Asa, how do you figure out covalent compounds? Uh, Now, this question is about chemical bonding actually. what happens is, let's talk about chlorides. Covalent compounds, they have less difference in electronegativity. So if you have a periodic table, what you would notice is which compounds form covalent compounds, the ones on the right, right? Why do they form? Like if you have Na and Cl, then the problem would be that Na has a very low electronegativity. It is electropositive actually. It likes to lose electrons, and Cl is the one that likes to gain electrons. So if there's Na and Cl, the electrons in the middle would, because Cl is so electronegative, it's eventually going to gain all those electrons, and Cl would become -1 and Na would become +1. Now, when you move towards Mg, Mg is towards the right of Na. Now, the difference in electronegativity is slightly lesser. So, if you have Mg and Cl and they're trying to bond with each other, Cl is still very electronegative. So, Cl is going to pull those electrons, and it would become -1. Mg would eventually lose 2 electrons, +2, and the electrons would be gained by Cl. But the thing is, it would have some covalent character. I mean, the electronegativity difference is now slightly lesser. So there's going to be some covalent character. Acha, but on the other hand, if you move towards Al, Al is again to the right. Now the difference in electronegativity is very less. So when Al bonds with Cl, Cl is still more electronegative. Cl would try to gain electrons. But now the thing is that the electrons are not going to be gained completely. And this molecule is actually covalent. AlCl3 is actually a covalent molecule, uh, because electrons are not, the difference in electronegativity is not very large. Uh, so it's a covalent molecule uh, with some ionic character. So it becomes the opposite. Its properties more resemble of a covalent. They resemble that of a covalent molecule. So aluminium is the one that would have the greatest tendency to form covalent compounds. Is this idea clear? Abba, is this
Yes,
clear?
sir.
You can, so, Ethan, Mohammed, is this clear? Isaac, clear?
Yes.
Yes. Yep.
Okay, so just remember this, that molecules or substances or compounds, they're not completely ionic or completely covalent. There's a lot of in between things. So if the difference in electronegativity is huge, then it's more likely to be ionic and less likely to be covalent. Uh, but if the difference in electronegativity difference is not that large, then it's going to show some covalent character as well. Which is why aluminium has amphoteric compounds as well. Uh, and it acts, sometimes it acts like a metalloid, and it usually forms, a lot of times it also forms covalent compounds. As the next one, which statement correctly describes what happens when silicon tetrachloride is added to water? We just did that. SiCl4 is going to strongly hydrolyze to form a precipitate of SiOH4, I mean OH4 plus HCl and fumes. It's going to be a vigorous reaction. So it's going to form a precipitate. It's going to react. It's not going to dissolve. Okay? It's going to hydrolyze, and it's going to give a precipitate and an acidic solution. The next one is the oxide and chloride of an element X are separately mixed with water. The two resulting solutions will have the same effect on litmus paper. So let's talk about sodium first. NaCl and its oxide. Now the oxide is basic. Uh, NaCl is neutral, so it's not going to have the same effect on the on litmus solution. Uh, so basic oxide would actually turn it blue. The next one is magnesium hydroxide and MgCl2. One of them is basic. The other one would actually result in an acidic solution, and both of them slightly. Like if we go back and look at our notes, what you would see is that I told you that magnesium oxide or hydroxide, they form a weak base. Why? Because they're not very soluble. They're not going to mix with water, and they're not going to produce a lot of OH ions because they're not any base that's not soluble doesn't mix with water, doesn't affect its pH. So that is what magnesium oxide does. Uh, it's hardly basic. And MgCl2 has very slight hydrolysis, and because of the slight hydrolysis, the pH kind of slightly drops to 6.5 or becomes acidic. So both of them, this would be weakly basic, this would be weakly acidic. So they're going to have opposite effects. As I then focus on aluminum chloride, the aluminum oxide is not going to it's not going to mix with water. AlCl3 is going to strongly hydrolyze and form HCl and fumes of HCl. So it's going to be strongly acidic. So one of them is completely neutral, wouldn't affect. So the correct answer is probably going to be D. That if you have phosphorus oxide P4O10, that would form H3PO4. That's strongly acidic. And if you have chloride, if you mix it in water, it's going to form H3PO4 again and plus HCl as well. So phosphorus chlorides they hydrolyze a lot, and if both of them are going to form acids. So the answer is D. The two resulting solutions will have the same effect on litmus. Uh, I said on this one, element X, Y, and Z are in period 3 of the periodic table. Element Y has the highest. So they are consecutive elements they are consecutive elements X, Y, and Z. So they're in a row, and they're in period 3. So which means they're right next to each other. So he's talking about the middle one, Y. He's talking about Y, and he's saying that it has the lowest melting point. So the middle one is going to have the lowest melting point. So let's have a look at the graph. What could be the middle one? Because it's going to have the lowest melting point. So if you look at the graph, the only possibility is phosphorus because three consecutive elements and the middle one has the lowest melting point. So it can't be NaMgL because the middle one doesn't have the lowest melting point. So it can't be anyone except this one. The three elements would be silicon, phosphorus, and sulfur because the middle one is going to have the lowest melting point. So it's going to be silicon, phosphorus, and sulfur, and the middle one has the lowest melting point. ठीक है? Is this clear as well? Minail, clear है?
Yes, sir.
अच्छा, so that would pretty much answer your question. He's also talking about ionization energy, that it has the highest ionization energy, the middle one. Uh, we can have a look of ionization energy table. How do ionization energies behave across the period? They rise. There's a dip at group 3, then 4 and 5 rise again. Then there's a dip, and then 7 and 8. So phosphorus is over here. So phosphorus is over here. Silicon and sulfur would be over here. So the middle one had the highest ionization energy and the lowest melting point. So it's going to be this one. So next is so the question states 1 mole of magnesium, aluminum, and sulfur are each burned completely in excess of oxygen. Which graph shows the moles used in each case? Starting with now, they have to be 1 mole. All of these have to be 1 mole. So Mg would form what? MgO. How many moles of oxygen do you need? You need half moles of O2. So have a look which one. I said then they haven't even labeled the y-axis. I said, what about the next one, aluminium? If you balance an aluminium with oxygen would produce Al2O3. I mean, you can balance this equation. There would be we can balance it the conventional way that we can have two aluminiums. That's four aluminiums, and that would give you 2 into 3 6 oxygen. So that would be 3O2, right? But he's talking about 1 mole of aluminium. So I need to make aluminium 1 mole. So I'm going to divide everything by 4. So how many oxygens do you need? You need 0.75. The first one needed 0.5. And then what about the third one? The third one is sulfur burns in oxygen produce SO2. Now remember, it's a minor point. Remember, whenever sulfur is burnt, it does not produce SO3. It always produces SO2. Uh, Producing SO3 is very tough. You need a catalyst, you need vanadium pentoxide, you need lots of things. So how many oxygens do you need if sulfur is 1 mole? That's 1. So it's zero point 0.5. The second one is 0.75 and the third one is 1. So that's like a linear graph. It's going to be A. It's going to be A. If this is zero point 0.5, then this would be 0.75 and this one would be 1. Every time there's a difference of 0.25. So it's going to be A. Is this clear as well? Zabe, is this
Yes,
clear?
sir.
Okay.
Yes, sir.
Acha, which statement containing the third period elements and the elements become more electronegative? That's true towards the right. Aluminum oxide is the only oxide which is insoluble in water. That's incorrect. Second is incorrect. The third is also incorrect. SiO2 is also insoluble. That's sand. That doesn't dissolve in water. The maximum oxidation state is not shown by silicon because chlorine has a lot of oxidation states. It could be +1, it could be -1, it could be +5, it could also be +7. So chlorine has lots of oxidation states. Now, you're given that the properties. What's Let's talk about this one for a second. Let's talk about this one. They're saying that he's saying that the properties of each period 4 elements resemble those of the period 3 elements. So basically, period 3 and period 4 elements, they have exactly or similar properties. Which period 4 element forms oxides that dissolve in water to give an acidic solution? So we're actually going to look at period 3 oxides. He's talking about oxides, right? So it's going to be phosphorus oxides and sulfur oxides, which means As and Se. So it's going to be A. Phosphorus oxides, they form phosphoric acid. Sulfur oxides, they form sulfuric acid when they dissolve in water. Silicon oxide is insoluble, it's sand. Aluminum oxide is also insoluble, although it's amphoteric, but these two are not going to dissolve in water. Now, this one is nitrogen and phosphorus are both in group 5 of the periodic table. Now, he's saying PCl5 can be formed, but NCl5 cannot be formed. What's the reason for that? Now, the reason there's a thing called octet expansion. What that thing is that if you look at nitrogen, it has 7 electrons, which means its outer shell has 2s2 and 2p3, which means 2px, 2py, and 2pz. So how many electrons does it need? It needs exactly 3 electrons. Now the thing is that the period 2, the second shell cannot have more than 8 electrons. That's the maximum. Like maximum you can have 8 electrons. That's it. So nitrogen cannot form or bond or accommodate more than 3 electrons. So it cannot form more than 3 bonds, whether they're triple bonds, double bonds, or single bonds, but it can't gain more than 3 electrons by sharing. But what about phosphorus? Phosphorus has 15 electrons. It's in the same group. Its outer electronic configuration is also exactly the same, except that it's the third shell. Now, if you remember, the third shell can have a maximum of 18 electrons because the third shell also has a d subshell and the 5d subshells 3dxy, 3dxz, 3dyz, and so on. So the thing is that phosphorus can gain 3 electrons, right? But it can gain a lot more than 3 electrons because the third shell is much bigger. And because the third shell is much bigger, it can accommodate a lot more electrons. Like octet expansion is that 1 electron, the electrons can get further distributed. And now 5 of these orbitals can bond with other atoms and can share electrons. Is this point clear?
Yes.
ठीक है? Remember this point. This is known as octet expansion. Bigger atoms, they always have multiple oxidation states. I mean, if you look at fluorine, fluorine is always -1 because it can only gain one electron. But chlorine can bond in a number of ways. It can increase, like chlorine's outer shell does not have 7 electrons. I mean, chlorine has 7 electrons in its outer shell, but its outer shell is the third shell, and it can have a maximum of 18 electrons. So chlorine sometimes also has an oxidation state of +7. The same with sulfur. It could have, like chlorine has, I mean, look at chlorine. What does chlorine do? It has 7 electrons, right? It's 3s2, 3px2, 3py2, and 3pz1. Now, it looks like it needs just one electron. But remember, it has lots of d orbitals which are completely empty. Okay, there are 5d orbitals which are completely empty. So what it could possibly do is that it can send one electron further down in one of the empty orbitals, and three of its orbitals could bond with other atoms. So that would give it a +3 oxidation state. Or it could send one more electron in another orbital, and that orbital can bond with some other atom. This could bond with some other atom. So now that's an oxidation state of 5. It could form 5 bonds. And the same, it could send this one electron to another atom, and both these orbitals could bond with some other atom, and that's what's that? That's +7. So chlorine can have multiple oxidation states. So bigger atoms, remember that when you have empty subshells, especially in the third shell, atoms in the third period or the third shell, they can expand the octets. In the second period, that's fixed. They cannot have more than 8 electrons. So oxygen is stuck. Oxygen can only gain 2 electrons, but sulfur can do a lot more because it has a lot more orbitals which are completely empty. Is this point clear, Ethan, Mohammed? Is this clear? Minahil, Rida, Hiba, Aba.
Yep. Yes.
Yes.
ठीक है. So the same problem is over here. Nitrogen cannot gain more than it can't bond with 5Cls because it doesn't have, I mean, it only has these three orbitals. That's it. I mean, there is no other orbital in the second shell. So the first statement, I said, why is it not possible? So you're saying, why is it not possible to form, Acha, so nitrogen, so the first statement is correct. Nitrogen's outer shell can only contain 8 electrons. The other two are not related to the explanation. I mean, that's the only thing that's explaining that. So only one is. I mean, the other two are correct, but they're not relevant to the question that they are asking. And so next one is, and remember, this also happens in noble gases as well. Like noble gases are inert, but the ones lower down in the group, they can expand the octet and they can actually form bonds. Like xenon forms bonds with other atoms. Neon doesn't. Helium doesn't because helium, its outer shell is complete. It has 2 electrons, one s 2. That's it. You can't expand it. That's the only shell in the first shell. That's the only subshell in the first shell. And so why does aluminum oxide dissolve in sodium hydroxide? Because it's amphoteric. So it can behave as an acid. So that's the reason. So this one is, which diagram best represents the pH of the resulting mixture? So all the oxides and the pHs. Remember, aluminum oxide and SiO2, they are going to be neutral. Although aluminum oxide is amphoteric, since they're not soluble, okay, since both of them are not soluble, and I think this is pH 7. Silicon oxide is weakly acidic, but it's weakly acidic only when it's concentrated NaOH. Doesn't do anything with water. Same with aluminum oxide, that's amphoteric, but that too reacts with very strong concentrated NaOH, not with water. So these three are acidic. I mean, we haven't studied this. This one is not in our course. So these two are correct. They're acidic, and the first two are definitely basic. MgO is slightly basic because it's not very soluble. Sodium oxide, the first one is The first one is very basic. So which statements are correct? So most of the questions are just aluminum chloride dissolves in water to give an acidic solution, which it does. Magnesium chloride dissolves in water to give a slightly acidic solution, which is also there's a slight hydrolysis. Um, Sodium chloride just dissolves in water, no hydrolysis. Nothing happens to water. So three is incorrect. Which oxides will react with to give a solution of pH 10 or higher? I mean, the second one is definitely correct. Uh, I mean, this is related to group 2. We haven't done that. Okay, let me just find if there's any other interesting question. Achha, just a slight bit of 1 second, maybe. So let's continue with this. Uh, Most of the questions are just straightforward, nothing that confusing. You just have to memorize all of the things on those 2 pages. Okay. So any questions about this? Is this clear?
Yes, sir.
Chale.
Yes, sir.
Okay then. Let's continue with this next class then. Okay.
Till Allah Hafiz.
Take care.
Allah
Thank you.
Allah Hafiz, sir.
Allah Hafiz.